Good morning, everyone. Great to see you slowly trickling in. Yeah, thank you so much for joining us today for the second day of the Lab to Land workshop. Okay, I think we have everyone in the room now who is in the waiting room. So yeah, good morning, good afternoon, good evening, depending on where in the world you're joining us from today. Yesterday we had folks as far away as Bangladesh and the south of France. So please feel free to introduce yourself and where you're joining from in the chat. And we've also just dropped a Mentimeter survey for you all to also share where you're coming from, and we'll share that at the end of this session this morning. And thank you all so much for taking the time and making the space in your schedules to participate in our 2025 Lab to Land workshop. Welcome to day 2, where we're going to be talking about where our discussions over the last couple of days have been centered around advancing water and soil research for agricultural resilience. I do want to take a moment to share with you all that this workshop series is being delivered in partnership between the BC Ministry of Agriculture and Food and the BC Agricultural Climate Action Research Network. I really want to say a huge thank you to the BC Ministry of Agriculture and Food and CleanBC for supporting this workshop. Their financial support really means that we can offer this workshop at no cost to our participants, and we can also make the session recordings available online through our YouTube page after the event. So just wanted to share a little bit about BC ACARN. We're a multi-institutional research network that was launched in 2017 out of UBC's Centre for Sustainable Food Systems. We bring together agricultural climate researchers, government, and industry to build strong collaborative research partnerships and drive development of innovative climate solutions. Our mission is to connect BC producers with reliable climate research and practical solutions. So we are a small but mighty team. I'm Dr. Love-Ese Chile. I'm the manager of ACARN, and I'll be facilitating this workshop and with my colleague, Asha Wareham, who is our project coordinator. And our team is also supported by Juliana and Subin, who do our communications and also support our knowledge translation efforts. And so our mission is really to advance and catalyze a resilient and thriving food system in BC. And to do this, ACARN provides a series of programs. Our team works with researchers and graduate students to translate research into producer-facing fact sheets, infographics, and research briefs. We also leverage our network of over 2,000 individuals to facilitate and host events for sector stakeholders to identify and coalesce around research priorities and also to drive collaboration on climate solutions. And we also work within the sector to support knowledge sharing around key priority topics and also to showcase new research, tools, and practices. And this is what's really bringing us together today for the second annual Lab to Land series. This workshop started in 2019 as a space for researchers to collaborate and set priorities. And now it's grown into this provincial online workshop that includes a very diverse audience that we have in the room. So before we dive into our presentations for today, I want to start by centering ourselves with our land acknowledgement. So maybe we can just take a brief moment to look out the window if you are sitting by one, or just sit with a gentle gaze or close your eyes and just really start to imagine. Think first of the soil, the earth beneath our feet, which holds us and grounds us, the space where our bodies eventually go to rest. Yet, the soil is not only our resting place, but it's a place of birth and rebirth. A seed planted in the soil can grow to nourish us, our communities, and our families. The soil in itself is made up of communities, of microbes, invertebrates, a whole biodiversity of creatures live in and rely on our soils, including ourselves. And as we connect our hearts and minds to the rich and sustaining force that lies beneath our feet, let us recognize how tending to the soils is a practice which we share with the Indigenous peoples who have lived in and cared for these lands and waters and soils for generations and continue to carry that knowledge forward. I respectfully and humbly acknowledge that the BC Agricultural Climate Action Research Network operates on the traditional, ancestral, and unceded territories of BC's Indigenous peoples. I'm a newcomer to Canada myself, and since I've landed on these shores, I've really tried to learn and be inspired by the teachings of our First Nation communities. And I've also seen their values reflected in the values of the Indigenous Māori people of New Zealand, where I grew up, and and my Tiv ancestors in Nigeria, which is where my family is from. Their teachings are that soil is a fuel that moves us, and we have a collective responsibility to protect and preserve our soils for the generations to come. The themes of stewardship and collaboration run through ACARN and through the workshop series that we've been hosting over the last couple of days. And today we'll hear from speakers and we'll learn about projects that are dedicated to bringing Indigenous ways of knowing to the forefront. So let's take a moment to pause and breathe and reflect on what we hope to get out of today. And feel free to note that down for yourselves. Okay, so let's dive into the session for this morning. So yesterday we discussed collaborative approaches to drought resistance. We had a great discussion on the watershed planning agreement that's being developed for the Cook Sila watershed. Natasha Overdoen shared with us their leadership, the co-leadership and co-governance strategy between the Cowichan tribes and the government of BC. During our project showcase after that session, we heard about the decision-making tools, funding and programs to support the provincial drought strategy. And the speakers shared specific examples of new data monitoring stations and nature mimicking solutions like beaver dam alternatives to really address some of the drought challenges we have in BC. And we wrapped up the morning with a facilitated discussion on evapotranspiration and plant-based approaches to optimizing irrigation. But today we're going to be focusing on soil and how we can support our ecological and community resilience. Our presentations will span soil health and resilience via Indigenous forest gardens, farmer-led research, and soil biology testing. So we'll be starting our day with a plenary presentation on restoring Indigenous forest gardens for ancestral soil stewardship. Later this morning, we'll go into a panel of farmer-led research projects which are advancing climate adaptation and mitigation efforts. And we'll wrap up our session this morning with a facilitated discussion around on-farm soil biology testing, and we'll have a space to network across different soil research areas. We really hope you can stay for the whole day, for the whole morning, but the sessions will be recorded and available for review at a later date. So just a bit of housekeeping before we dive in. As I mentioned, the session will be recorded and you'll be able to get access to them through the BC ACARN website and also our YouTube channel. Please feel free to use the chat box to share your thoughts on the presentations and if you have any kind of following up discussions. But please add any questions to the Q&A chat box. There'll be, at the end of each session, there'll be ample time for Q&A. And so, yeah, please feel free to add your questions and upvote the ones that you want to be answered because we'll go from the top of the list. We also have captions enabled at the moment, so feel free to hide these if they're not helpful for you. You should be able to see the caption option on the toolbar at the bottom of your screen. Okay, so let's dive in to the first session. So to begin with, it's my absolute pleasure to have JT Cornelis and his team from the Soil Res 3 Lab at UBC joining us today. So the Soil Res 3 Lab focuses on studying the interactions between soil processes and the cycling of essential elements in terrestrial ecosystems, especially as they respond to both natural changes and human impacts. Rooted in plant soil feedback, Dr. Cornelis's team explores the intricate soil land and people relations in diverse eco-cultural contexts, striving to enhance ecosystem resilience. Through respect and reciprocity in relationships with Indigenous communities, JT's team is committed to decolonizing the discipline of soil science to inform the reintroduction of Indigenous practices, thereby supporting the effort of the land to, sorry, thereby supporting the effort of the land to maintain a stable homeostasis. JT is joined today by Jack Edgar and Kristen Pundyk, who work towards the revitalization of Indigenous soil amendments, and Alyssa Robinson, who investigates how ancestral Indigenous forest garden practices influence soil processes and properties. So I will bring them up to the stage and let them take it from here. Brilliant. I think you should have control now, JT.
Okay, cool. Okay, perfect. Okay, thanks, Love-Ese, for the introduction, and also thanks again for inviting part of the Southwest Tree Lab to contribute to this workshop organized by ACARN. So thanks a lot. Um, so yeah, I wanted to start to acknowledge that the Southwest Tree Lab is located on stolen land from the traditional ancestral and unceded territory of the Musqueam people. And on my very personal view, so I'm JT, so Jean Thomas. The full name in French is it's Jean Thomas. So I'm from Belgium by birth. Today in Belgium, but I'm a settler in Vancouver for 4 years. And both of my grandparents were farmers and foresters, and I'm also a dad of two little boys. So yeah, I'm super excited to be here today to talk in this workshop, and thanks again for the opportunity. And so, as it has been already explained by Love-Ese, so my team in the Southwest Tree Lab are really into respect, of course, and reciprocity in relationship that we are building with the different communities with who we are doing co-research. And the very objective is to work to listen, to ask questions, to take feedback and create impact driven research with the aim to shift conventional thinking about to shift the very conventional thinking towards fluid approaches and greater environmental justice. So that's the very ultimate goal of doing the research in my cell science lab. And so we are lucky enough to work and to do co-research with and for different indigenous communities. So Kittilas First Nation, so you will see today we're gonna talk a lot about the co-research we are doing together, but we have also projects and co-research with Chelas, the Coast Salish people, and also from the Lutkuzi was Wilp from the Gixan territory, but also Gitsegukla Wilp, also from the Gixan territory. So yeah, that's a very teamwork with indigenous communities, but also with other lab from Western science and indigenous sciences. So the first one, we are collaborating a lot with her lab. So that's the lab of Chelsea Armstrong. She's an archaeologist, a historical ecologist, it's a botanist from SFU. And we are also working with Jennifer Grant, who is leading the Indigenous Ecology Lab at UBC. So it's a very teamwork, and we are learning a lot over the process. So just very briefly, a very brief overview of what we are doing in the Southwest Tree Lab. So the very principle, let's say, also philosophy is to apply the theory and what we know about the Western science from pedology and terrestrial biogeochemistry to better understand soil plant feedback. So what does it mean? It means that we are diving into the very soil micro scale processes, soil genesis principles, and trying to understand how those processes can influence, partly control the very response of the macrostructure. So the ecosystem response in terms, for example, of carbon cycling, nutrient use efficiency, microbial diversity, that kind of things. But the very entry point is soil genesis and soil physicochemical processes. So that's the Western science background of the lab, and with the very objective to try to improve ecosystem resiliency. So that's, yeah, very rooted in soil, land, people relationship, and I love to do some sort of comparison with surrealism because I'm from Belgium and I'm a huge fan of surrealism, like the one from René Magritte here, the paint La Décalcomanie. Um, and why? Because I think there is some sort of relationship between surrealism and the type of science we can do with the different communities, because surrealism, what it is really trying to define what is out of sight, out of mind, and not really defining, but trying to understand, getting a view of what is out of sight and out of mind. So that's the very depiction of familiar object in unfamiliar context, which really often raises a question about the nature and boundaries of reality and representation. And I think it's also certainly the beauty of combining Western science with traditional ecological knowledge. So just to give you a little context about what we're gonna talk about today, this morning with Alyssa, Jack, and Kristen. So we are really in the context of a puzzle. So you know what is a puzzle? In a very nutshell, it's a very that's a very challenging soil into through the lens of fertility in terms of soil quality, or if we are only thinking about growing plants, it's super challenging. Why? Because it's a type of soil that is very depleted in terms of nutrients and with a very poor water retention. It's very sandy, and that's a very beautiful soil. That's picked from a puzzle from Belgium. You see the different colors, but because of the acidity, something that is very sandy, water and nutrient retention is really bad. And so it means that for growing food through the very Western vision of production, it's super challenging. I think it's the most challenging soil, together with the soil that we can find under the tropics, like the oxysol from the US classification, or feral soil from the WRB classification. So yeah, it's super challenging, and that's really the type of soil that we can find in the Pacific temperate rainforest. And I think we are a bit biased by from the very dominant Western vision that, okay, the type of forest ecosystem are only pristine, that's the wilderness or untouched ecosystems. Maybe because, yeah, we think that's only podzol and very temperate rainforest with, okay, a huge biomass, but not really the type of ecosystem that can help to produce biodiverse ecosystem or food system. But it's a myth, and you will see today through the data that we have with Kitsenas put together that it's another story. And so that's the story of the forest garden. And I think that's a really lovely one because we have the very indication here on the left side of the peak here. It's a very typical puzzle from a temperate rainforest that we have in the Pacific Northwest. And on the right side here, you can see it's completely different. You have a very deep, darkish horizon. And so it's more like a sombric horizon in a podzolic context. So that's the very indication of a human-influenced soil genesis in indigenous forest gardens. And you will see through the presentation by Alyssa that, yeah, It's changing everything in terms of nutrient, in terms of carbon. And we have a wonderful example in the forest garden. So you see the forest garden is very located close to the village here. And if you are going a bit further in the forest, you can get a what we call a periphery forest. And you will see the properties of the soil are completely different. And I think we can really revisit the way we are thinking about soil fertility, soil quality, but also soil health concept. Because here, I did some sort of job and research also with indigenous communities in Africa. And I think we have here the example of a very sophisticated ecosystem that can build and improve what we call soil health while producing food in forest ecosystems. So that's a very vision that can help Western research to shift into a new type of agriculture that indigenous people know for millennia. And so that we really need to revitalize, certainly in BC and beyond all over the world in terms of ancestral practices. So it will be the story of what we're gonna present today, this morning. And I'm again deeply grateful to the Kittilas people for having us on their territory for this co-research and for their generosity in sharing knowledge and the opportunity to co-learn together between Western science and traditional ecological knowledge. So thanks again, and thanks again to ACARN for this opportunity. And Alyssa, I think the floor is yours.
Awesome. Thank you, JT. Hi, everyone. I'm Alyssa. I'm a new second year student PhD student in JT's Soil Res 3 lab at UBC. I'm also co-supervised by Chelsea Armstrong from the her lab at SFU. I am a white settler of English and French descent. I was born in Treaty 7 territory in what we now call Calgary, Alberta, and I came here to UBC in 2016 and have been living on Musqueam territory since then. Both my parents are scientists. I come from a family of scientists. My sister is a scientist, and my whole life I was taught and led to believe that science is objective. And while I think that that is still true and can be true, I also believe now that science should be and can be led by emotion and by feeling. And it is my philosophy and belief to carry whatever emotion and feeling it is that led me to a project throughout the entirety of the project. And with that, I hope that I carry the right feelings through this project. With that, we have had the pleasure to work with Kittilas First Nation on their forest garden project. A little bit of background. So they have been working with Chelsea Armstrong for years and years. Chelsea is an amazing archaeologist and ethnobotanist, and she has dug a bunch of archaeological pits in the soils in these forest gardens, and through her and her team and all the people that she's worked with in the canyon, they came to this realization that there's something really special about the soils in these forest gardens. And so in came JT and in came me to join them in their journey of understanding what it is that is special about these soils and how they can recreate them to revitalize these soils. So the short term, oopsie, forget that I have to use my cursor here. There we go. In the short term, they have a couple objectives, and in the long term, they have some objectives. The focus of my work is on the short-term objectives, which is how are these soils formed, what do they look like, and what are the properties of these soils. And then using those properties, Jack and Kristen will be discussing how can we recreate these soils? Is that something that we can do? So JT gave a bit of background on forest gardens and forest gardening, but just to give you a little bit more context, forest gardens are deciduous native plant food sheds. They're composed mostly of things like beaked hazelnut and Pacific crabapple, and they're found near archaeological village sites all along the coast. They're quite common along the coast. And these are managed ecosystems and shaped ecosystems. There's this myth that has been perpetuated through history due to colonialism that Indigenous people were not managing their ecosystems and not shaping their ecosystems, and that is simply not true. And forest gardens are an excellent example of that. Forest gardens in particular were shaped by local or landscape level burning. They were fertilized by fish bones. Many species were planted or propagated or transplanted. Species were pruned. If you know, I'm sure you're all familiar with apple trees, and there was tons of Pacific crabapple. Pacific crabapple loves to be pruned, and it can help create abundance. And of course, forest gardens were weeded as well. Pull out what you don't want so that what you do want can grow. So these were shaped ecosystems and they were managed ecosystems, and people were practicing the shaping for millennia. Unfortunately, due to our colonial history, the forest garden that we're looking at today has not been managed for the last about 150 years due to the forcing of people from their land to reservations and the disruption of management practices. So this is the forest garden we're looking at. This is Kitsilus Canyon here and the Skeena River. It's kind of near Terrace, BC, if you know where that is. Typically, you'll find your village site. Can you guys see my cursor? Probably not, eh? No. Okay. Well, you'll just have to imagine with me. You've got your village site closer to the river. Behind it, you'll find your forest garden. And then behind that is the periphery forest, which JT talked about. For this project, we dug 3 soil pits in the forest garden and 3 in the periphery forest. And we compared the properties and processes occurring between the two. We call it a periphery forest in this context because we don't really like to use the term and don't want to use the term control forest. You'd be really hard pressed to find a piece of land near a village site that was not used and occupied by people. Therefore, it is not pristine, it is not untouched. Again, that's a myth that a lot of land in British Columbia in Canada was untouched by people. Land was used, land was occupied, and land was shaped. So yeah, 3 soil pits in each forest. And we ran some lab analyses. We took the pH, the cation exchange capacity, the total nutrient concentration, and the bioavailable nutrient concentration. And then we calculated 2 properties. Number 1, the base saturation. I like to think about that as like the current nutrient supply for microbes, for plants. And then we also calculated something called the total reserve of bases. And I think about that as like the future of nutrient supply. So you take an entire mineral, you break it down, and you take the total concentration of all of the elements in it, and then you add up the calcium, sodium, potassium, and magnesium. And in the long term, those are going to be supplied as weathering occurs. So it rains, minerals break apart, and eventually those nutrients become available to plants. So that's your TRB, your total reserve of bases. Amazing. There we go. So JT showed this photo. As you know, the soils are very different. They're both podzols, yes, but in the periphery forest, you're going to find an orthohumic podzol. That's a very typical as it gets podzol. You have a more humus form, not a lot of biological activity. You've got a very stark and abrupt boundary between your forest floor and your mineral soil. And then in the periphery forest, or in the forest garden, you've got that huge AH horizon, and that AH horizon is super, super dark in color. And that's where all of the action is happening. We're finding tons of fire-cracked rock in there, tons of fishbone fragments, micro charcoal fragments, earthworm activity. So it's a super active part of the soil. And that's reflected in the chemical properties, which I'm about to show you. So here, as you may guess, the carbon is significantly higher in the forest garden compared to the periphery forest. We've got about 15% carbon. With that, the nitrogen is also significantly higher in the forest garden. Those are in the blue there. And really, really interestingly, the C to N ratio is significantly lower in the forest garden. And this is super indicative of a super biologically active system. We've got lots of nitrogen to carbon, like tons of available nitrogen as well. And that is keeping our C to N ratio really low. And I'm sure many of you know, as you're agronomists and soil scientists, that that low 12 CN ratio of about 12 is really what we're looking for when we're trying to grow food. In the periphery forest, the C/N ratio is fairly typical of a conifer forest. This conifer forest in particular is in the coastal western hemlock ecosystem in the Beck zone. So it's mostly occupied by hemlock. So I would say that value is fairly typical there. Moving on. pH, again, just as we suspect in the periphery forest, we have quite a low pH. It's a podzol, it's an acidic soil. This pH is particularly low, around 3 in the upper AE horizon, which is very, very acidic. But on the flip side, in the forest garden, in the AH horizon, we've got a pH of almost 4. So we're kind of reaching that threshold where we're avoiding the aluminum toxicity. And again, thinking back, this ecosystem has not been shaped for the last 150 years. So we suspect that it probably would have reached that 4.5 threshold 150 years ago. Moving on to the CEC, again, huge differences here. The CEC in the forest garden is around 25, like that is massive. We have, through the AH horizon, increased the capacity of the soil to hold nutrients. And with that, the base saturation is also incredibly high, around 80. So we've increased the capacity to hold nutrients. The soil is holding more nutrients. And finally, with the TRB, just a reminder, this is the long-term supply of nutrients. Our TRB is super, super high here. So we've got a higher pH, we're avoiding aluminum toxicity, we've increased the capacity to hold nutrients, it's holding more nutrients, and the soil has a long-term supply of nutrients. For a little bit of context in the TRB, a TRB of around like 80 is typical of a luvasol, something rich in nutrients, and then maybe an oxisol is somewhere around 20. So again, this is like, we've got very, very stark differences here. This is kind of my last slide for chemical properties. And super, super interesting here. So the calcium, if you look at that kind of pinky bar on the left, the calcium is incredibly, incredibly, incredibly high in the forest garden, like just significantly higher than it is in the periphery forest. And that we can probably attribute to fishbone fertilization, right? If you're fertilization with fish bones, which are high in calcium carbonate, your calcium is going to be absolutely through the roof. So yes, the calcium is significantly different. We're also seeing huge differences in phosphorus, manganese, magnesium, all of the zinc as well. All of these nutrients are being found in much greater quantities in the forest garden. So to me, all of this together just says that these soils are managed in such a sophisticated way that there is a really beautiful nutrient circularity to them. Like the soil, plant, people, river connection is so intertwined in that these soils can circulate the nutrients so beautifully to the microbes, to the plants, to the people, back to the river, and so on and so forth. And you really can grow food, and a lot of food in abundance in these forest garden ecosystems. And they were growing food in abundance in these forest garden ecosystems. They're very, very cool. So if you get a chance to see one, head to Kitsilus Canyon. Darren will give you a tour. He's super cool. And I think I have one more, next steps in future research. We want to dig a bit more into that AH horizon, what's going on there. Why is it so resilient? Why is it still here 150 years after the cessation of management, and looking into that charcoal as well. And with that, I'll pass it on to Jack and to Kristen to talk about how we're going to take these results and use them to work towards revitalization with Kitsilus. Awesome. On to you, Jack.
Sweet. Thank you so much, Alyssa. I really appreciate it. Yeah, so just to give you a bit of context about myself, my name is Jack Edgar, and just to note, I also am a white settler who I moved to BC about 13 years ago from Denver, Colorado, where I grew up on the traditional and ancestral territory of the Arapaho, Cheyenne, Ute, and Dakota peoples. And throughout my learning journey, I really strive to remember the wise words I heard a while back from the Musqueam elder Larry Grant, and that is that we have two ears and only one mouth for a reason. We need to be listening at least twice as much as we talk, and that is especially true in this work that we're doing here. So I've been working with the Soil Res 3 lab for the last 2+ years as the lab manager / coordinator. And before that, I worked in farming and market gardening. So that's one of the reasons why I was particularly excited that we got to present and share to this agrarian and agriculturally minded community today. And it's been an absolute privilege to work on this forest garden research project, echoing what JT and Alyssa have said so far. And, I want to express my gratitude for all those who have come before us to do so much work to know where we're at today, and for the totally generous collaborative spirit of Kitselas and the other communities that we work with for sharing their knowledge. It's really a gift. So yeah, why are we interested in revitalizing forest garden ecosystems? Well, at the very basis of this, the revitalization of Indigenous forest gardens is Indigenous food sovereignty. And it's the revitalization of cultural practices, both of which are inextricably linked to the land, making these practices tangible actions for communities to connect back to the land. And knowing our agrarian audience today, I'm sure many of you are wondering and are asking yourselves, well, how much food can we produce from these forests? And what is the yield? And questions like these. And I ask you to, put those thoughts to the side for the moment and think about how, although the true production potential is somewhat unknown right now, at this point in time, that's less important, the sheer quantity of food that can be produced, but more importantly is the opportunity to grow these culturally relevant foods and reignite Indigenous ecosystem stewardship in these unique forests. And it's also important to consider that these culturally relevant species will differ between communities and also over time. And for example, through some of the conversations I've had with various communities on this subject, there's also interest to explore other potential non-native fruit tree species, which the elders of today grew up enjoying in their youth. So it goes without saying that these forest garden revitalization projects must be led and designed by the Indigenous communities themselves. But, that should be obvious. So, and then we'll also touch on a little bit near the end, the fact that these are biodiversity hotspots in a landscape, and they have a unique opportunity for wildfire risk management, which I think is some emerging perspectives of forest gardens when we start to look at them at a landscape scale. And then here's a couple photos of the Gitaic forest garden as Alyssa was sharing about just before. So in Kitselas, we've been working directly with Patsy Drummond, who manages the Kitselas Growing Food and Wellness Program. And Patsy was hoping to join us today, but unfortunately is not able to after all. So I'm going to try my best to fill in a little bit of information about the program. But if you have more questions after this, feel free to connect with us and we'll get in touch. Currently, the project has built a greenhouse, which you can see in this photo here. And cool enough, there's a really productive peach tree that lives in that greenhouse, which I think we'd all agree is pretty unique for the latitude of Terrace Kitselas. There's also a mixed vegetable community garden, which you see here in the foreground, and a nice little berry patch. And a part of this program throughout the growing season, they have weekly produce pickups for the community, which are also supplemented by a local farm from Terrace, Farmer Cam's Food. And he's also been, coming and providing some guidance on growing practices in this, more Western, Euro-Western style of growing. And they also host, a series of engagement and learning activities throughout the season. So the next milestone for this project is to plant and develop a demonstration forest garden. And the space designated for the demo forest garden is conveniently right across the street from the community garden. They just recently received confirmation that they'll be able to use that space. It's just around 1/3 of an acre. And the demo garden will first and foremost be a place for the community to gather, enjoy, and revitalize these cultural food systems. At the moment, Kitselis doesn't have any formal parks or outdoor gathering spaces. And so this is a unique opportunity as well in that sense, to have a nice shared space for the community to gather and be with the land. An added bonus to this project, the demonstration forest garden, is that it's also going to be acting as a living lab for applied research about forest garden revitalization. And as we know, sadly, so much traditional ecological knowledge was lost during colonization. And so as both researchers and Indigenous communities alike, we still have much to learn and relearn about forest gardening practices, and especially how we can apply these today with the modern tools we have to use. With that in mind, we don't truly know the production potential of forest gardens, and that will be really exciting to develop over time. And like Alyssa said, there's, from pruning and fertilization and low intensity cultural burning, really, it's, the sky's the limit. So that's a really exciting component to consider as we move forward. So included in this demo site project, there'll also be the addition of another greenhouse that is solely dedicated to the propagation and growth of forest garden species. This will be used to not only plant out that demo forest garden site, but then to be distributed to the community, and then the Kitselis community. And then once everyone is satisfied there's the opportunity to continue growing those to distribute to the broader community in that region. And I think this, there's also going to be a master's student who is going to be helping do research on how to optimize the propagation and growth of those forest garden students. And I see this production and distribution of forest garden species at a broader scale as one important step in healing for both communities and ecosystems. So really excited to see that grow here and other places around the province. So in addition to the propagation and planting of these forest garden plants, our lab is taking on the role of researching and developing methods to optimize the soil properties in this new demo forest garden to most closely match those of historic forest gardens. And our goal is to create a compost soil amendment with some of those ancestral practices mentioned earlier in mind. And Kitselis presents a unique opportunity where the salmon processing and smokehouse hub is also located directly adjacent to the community garden. And so the community, in partnership with our lab, plans to develop a community scale composting system utilizing the salmon residues from that hub to produce a forest garden-esque compost, if you will. And so I'm going to pass it along to Kristen to talk more about that stage of the project.
Wonderful. Thank you, Jack. All right. Hi, everyone. My name is Kristen, and as JT mentioned at the beginning, I'm a master's student in the Soil Res 3 lab, supporting this revitalization of Indigenous forest gardens through primarily a community-led investigation of traditional soil amending practices. And so really driving this is an exploration of how traditional land use and forest stewardship can inform and improve contemporary soil practices, properties, and overall food forest garden ecosystem resiliency here in BC and beyond. So to start things off, I'd first like to acknowledge how I situate myself in this research. I'm a settler who grew up on Treaty 7 territory in southern Alberta, with the privilege of now living on the traditional and unceded territory of the Musqueam people while I attend UBC and do this research. I feel very honored to be working in collaboration with Kitsilus First Nation on this project. And as a settler, I don't by any means claim to be an expert in traditional soil amending practices, but I am speaking to you today as someone who is really learning and growing and being deeply shaped by this work with Kitsilus as we support forest garden revitalization and food sovereignty in the nation. So with that, let's dig in. All right, so as mentioned, Kitsilus is interested in amending a site in their community to serve as a demonstration forest garden. And my piece of that puzzle is co-researching a compost amendment that emulates the properties of forest garden soils in a way that really honors traditional soil stewardship. And so that looks like a mix of salmon remains from community processing, biochar that we'll be producing on site. That's a charcoal soil amendment that I'll speak to a bit more in the next slide. And we'll also be mixing that with wood chips. And so quickly, I'll just kind of go over why we are using salmon and biochar. As Alyssa mentioned, salmon has been used in forest garden soil amending for millennia, resulting in that really nutrient-rich forest garden soil that we're observing today, even 150 years after active management. And in addition to this, frequent low-intensity burning, which had various objectives from community to community, could include increasing the quality and quantity of berries in forest gardens or preventing conifers from encroaching on the fruit and nut-bearing trees, deciduous species. But it also resulted in a large addition of charcoal to the soil over time, which led to that very large carbon pool that we're observing in the traditional forest garden soil. So what is biochar? I'm sure lots of you already know, but I'll just kind of highlight the main pieces. Biochar is organic matter, and in this case, our feedstock that we're using is wood chips that undergoes the process of pyrolysis, which is the thermal transformation of biomass at a high temperature in an oxygen-limited environment. So the result is essentially a charcoal that is one of the most recalcitrant forms of carbon that can remain stable in the soil for the time scale of hundreds of years. And because of its uniquely charged surface and porous structure, biochar is widely recognized as a soil amendment that can not only increase the pool of stable carbon in the soil, but also enhance a wide range of other properties, such as increasing the pH, the cation exchange capacity, so the ability of that soil to hold on to nutrients and water, and also supporting beneficial microbial growth. So we can think of all those little pore spaces as little microhabitats. So the salmon is the nitrogen-rich input in our compost, and it will provide a lot of the nutrients that will then be better retained by the biochar. Our hope is also that adding the biochar into the compost mix will also mitigate some of that odor that could potentially be a concern with composting fish. And then also, I'll just note that co-composting biochar with organic matter further improves those soil properties while mitigating any potential negative consequences that may arise from applying it to the soil in pristine form. So essentially by composting it with the organic matter, we're charging it with nutrients that will then be used by plants and microbes later. And so I'll next touch upon what we're doing at UBC right now. So we are about to begin our first small-scale batch of the salmon biochar wood chip compost. We were able to source some coho from a local fishery, and we're building what's called a top-lit updraft gasifier, or TLUD, which is a fancy way to say that we're making biochar, and which is the same method that we're using up north, and it's an affordable and relatively easy method, or easy to build method of producing biochar. We essentially repurpose a 55-gallon barrel and add a chimney. And yeah, what you can see in this photo here, we were able to build in less than a day. And I guess it's worth mentioning too that it's a relatively small scale way to produce biochar, which is suitable for the demonstration site, but other options do exist to scale up if that's the desire. So once we have our biochar, make the amendment, and then once the compost has time to cure, our plan is to test different application rates in a controlled environment at UBC. And the idea is to figure out what the optimal application rate is that can then serve as a guiding point for amending the demonstration forest garden. And knowing the application rate will also help us, or will help with a future graduate students research that Jack mentioned, who will be based in Kitselis doing a lot of the forest garden species propagation in the new greenhouse. And then we'll also analyze the effect that this amendment has on various soil properties, so carbon and nitrogen, available nutrients, pH, CEC. So that's in the lab. And then beyond what we're doing here at UBC, so in the spring, we'll be setting up a compost bay in the community, so in Kitselis, so we can initiate the process of like building soil at a community scale. And as Jack mentioned, the community smokehouse is adjacent to the community garden site. And so that's, yeah, really wonderful when thinking about the concept of nutrient circularity. As Alyssa mentioned, the salmon is coming from the river and we're making the biochar right on site, making the amendment there, then amending and using it also to support the propagation trials. And then I guess one last thing to mention as well is that we'll analyze the resulting effect that this amendment has on the soils in the demonstration site and compare it to the soil of the traditional forest garden site. Yeah, and so that's what I'm working on. And I guess I'll just summarize by saying that our goal with this is to really use a modern understanding of what Indigenous communities have known and practiced for millennia to build soil with what is locally abundant in a way that honors traditional soil tending, soil stewardship, and really supports the community's food and land sovereignty goals. And so with that, I'll pass it back to Jack.
Awesome. Thanks, Kristen. So exciting, the next steps in that project. So I just wanted to, before we end today, to leave us all with some inspiration to dream about what the future of forest gardens can look like across the province and beyond. Not only, as mentioned, not only do forest gardens hold the opportunity to produce local, culturally desired foods, community gathering places, and research hubs, but these ecosystems also offer enhanced biodiversity, and I think of especially poignant interest right now, wildfire mitigation potential. According to FireSmart BC, beaked hazelnut is actually considered a fire-resistant shrub species, and crabapple is a fire-smart choice as well for landscaping. And both of these possess the ability to decelerate the growth of fires. So as shown by both JT and Alyssa earlier, historically, forest gardens were located adjacent to village sites, obviously for easy access of management and harvesting. And we're currently at the stage of small demonstration sites like the one that we've just described here. But I challenge you to envision this at a larger landscape scale. And I like to imagine a future where communities, again, surround themselves with forest gardens, not only for food, but as a fire break buffer. And in order to solve our most pressing and hazardous ecological challenges, such as fire, in the face of a changing climate in particular, we really must develop and support multifunctional solutions such as this. So this is kind of a far out thought for forest gardens, but like I said, we're just kind of dreaming today about that. And as more forest gardens are rehabilitated and replanted in Indigenous communities around the province, I really look forward to seeing the growth of collaboration between communities to really further the shared goals of Indigenous food sovereignty and this reconciliation in action. So I leave this to the collective to dream about how we can all support the revitalization of forest gardens. And yeah, so that's this here is just a little, image of what that could look like, a buffer around, this is the Kitsilus community, satellite imagery here. And yeah, I want to thank you kindly for your attention and participation today. And I think we still have a little bit of time for questions.
Yes, we do. Thank you so much for that presentation. Let me just stop the share so we can all be up here together. Yeah, thank you so much. It was so wonderful to learn about, I guess, using modern science to kind of corroborate what people have been trying to tell us for a long time, that Indigenous populations really have been caring for this environment in their really unique and special ways for for longer than we can even imagine. So it's great to see we have some questions in the chat. And thank you for answering some of them. But I do want to bring one of them up, which I thought would be really great to kind of follow up on. I really appreciated the approach that the four of you have as researchers stepping in to try to work with Indigenous communities and just kind of learn from them at the same time as providing, additional like stories to kind of further corroborate kind of the work that's being done. So we had a couple of questions in the chat about how this approach might be able to be taken in other communities across the world, and how what learnings might we be able to share to kind of continue to amplify Indigenous ways of knowing, both here in Turtle Island, across Canada, and in other places where colonialism has kind of narrowed the scope of the knowledge that we hold and uphold. Feel free to unmute and jump in, whoever.
Maybe.
Sorry, go ahead.
Yeah. Okay. Yeah. I'm gonna go with. I'm gonna take the question about how have wildlife interactions attractants being taken into account in that kind of ecosystems? That's a good question, and that's a very ecosystem. So what has been observed in the field also with the communities is that forest garden is a very hot spot for wildlife. Of course, that's exactly the place where I will be going to get berries, to get everything to eat. So there is a lot of interaction between wildlife, forest garden, the villages over there. So it's really part of the system. And I'm not saying that it's not only, for example, bear activities in the forest garden that is really affecting or controlling, influencing the soil properties, but that's a whole. And there is certainly part of a contribution from wildlife, but not only, because when we are seeing so high concentration of phosphorus, for example, to take the other question, Alyssa was explaining that it's certainly because of interaction between calcium and phosphorus, calcium coming from fish bones, for example, phosphorus also certainly, and also from other bones. All together, they've been able to build a pool of organic carbon in the soil. So plenty of organic molecules coming from prescribed burns that are also the support to create cationic bridges between phosphorus, calcium, and organic molecules. So that's really the ancestral practice that can really sustain the bioavailability of nutrients. And it's certainly related with the question from Chelsea about conventional agricultural practices. I don't know if other people want to jump here, Jack, or
Sure, yeah, I could take a stab at that. Yeah, it's a great question, Chelsea. And just if those haven't seen it in the Q&A chat box, Chelsea was wondering how some forest garden practices could be applied to a conventional agricultural system. And once again, I think that's a great forward-thinking approach for us all to consider as we move forward. I'd say first and foremost is the biodiversity component. Like, these certainly were not monocultures. And so starting to really develop and design polycultures that work obviously within our current systems and scale of food production, I think is key. And then also, thinking of our relationship with the soil as something that is, you know, reciprocal, and that we are giving and fertilizing to the soil also with local materials. You know, what does your community have in abundance that could be possible, that is maybe a waste source that could be made into biochar? Or is there a substantial nutrient surplus in terms of food waste? Or, you know, in this case, there was fish residues that were used as a nutrient source. So I think just really thinking about that local circularity in terms of nutrient cycling and carbon cycling, I think are the best ways that we can kind of consider and apply that to our modern conventional agricultural systems. If anyone wants to add anything more.
Actually, yeah, we can kind of connect that to someone else's question as well. Someone asked if we'd explored the idea of seaweed as an additional amendment. And seaweed, while definitely has been used as a fertilizer by Indigenous people, was mostly used in estuarine root gardens, not necessarily in Kitselis. So a goal of our work is to do very place-based work. And in Kitselis, Kitselis is like kind of more inland. It's coastal, but not quite. And so seaweed would have been traded, but it probably would have been eaten. And so it probably was not a amendment that they were using. And so they would have had it and consumed it, but it wouldn't have been a fertilizer. That being said, kelp and seaweed is definitely something that lots of people are looking into, and has been used for millennia by Indigenous people. Great question.
Yeah, and
Kristen, oh, go ahead. Sorry.
Oh, sorry. Yeah. Okay. Thanks. Yeah. One little thing, because it's pretty related also with the great job the Ministry of Ag and Food is doing about investigating soil health principles and parameters. And I think it's also an example that I think soil health concept is really an ecosystem property. So we really need to investigate the principles of an healthy soil, not only in terms of parameters that we have from the soil, but also in terms of the response of the ecosystem and the relationship with people. So yeah.
Well, thank you
Kristen,
for
I see
those.
there's a question about the chosen ratio of fish to wood chips to biochar. Do you want to take a stab at that?
Yeah, absolutely. That's a really good question, and something that we spent a lot of time thinking about and reading about for sure. We went with the kind of 1 to 3 fish to chips, fish and chips. Um, ratio mainly because that's what's been done in the literature. There were some studies or some trials that happened out on Vancouver Island looking at salmon composting, and they tested different ratios, and that's kind of what they kind of found was optimal. We also, played around a bit with different CN ratio calculators online that are available through many different sources, and just kind of played around with our different ratios until we got a CN of the compost that was kind of between that 20-30 mark of what we're looking for in the compost itself. Yeah, I hope that answers your question. And then I also saw a question in the chat just related to this about why we're using salmon and if other fish could work. And that really ties back to what we're talking about this project being super place-based. And so the stories that have been shared with us is that it was salmon, being used as a forest fertilizer in this specific place. And so would other fish work? Probably, but that's not what we're kind of looking at in this context. But if other communities are using, other types of fish or other types of, fertilizing sources, seaweed, it really depends, and it changes across the landscape from community to community. And I think something that is worth highlighting too is that like this isn't a prescriptive soil amendment or something that could be like a marketable Indigenous amendment. No, that's not what we're doing. It's like place-based soil building. And so the salmon and biochar is something that the community is really excited about. Yeah, so I hope that answers your question.
Great, thank you so much. I just want to circle back to a question that came up, which was answered via a typed message, but want to bring, just so that everyone can kind of hear the answer. It was really just around how your experiences within this project could support the challenges of poverty and food insecurity in other regions. So thinking about places in Africa, Asia, and Latin America. Do you, if you could speak to some strategies that you used engaging in your research, which people might be able to use in other regions as well?
JT, do
Maybe
you want to
JT, you can jump
touch on
in.
that?
Okay, yeah, good. Yeah, I was just saying that we did some of co-research with indigenous communities in Africa, in Burkina Faso, and so yeah, it's always, you know, when you want to get some sort of good research outcomes, so sustaining really the outcomes for the communities. The very key thing is really to get community-based research and together with place-based knowledge coming from the farmers, coming from the researchers, from the very Western science. And what we have observed in those regions is that by using really the residue, the waste, there is another question about waste. It's a really good idea by producing biochar. So biochar, it's not a question of getting a very huge quantity of biochar that you can apply, for example, at 20 or 30 ton per hectare. That's a nonsense because, for example, in BC, if we are just thinking about the forest waste residue that we have, and you know the very high productivity of forest ecosystem in BC, you know what is the rate of biochar that we have on an annual basis? It's only 1 ton or 2, maybe 3 ton per hectare. So when you are seeing publication where people are testing 20, 30, 40 ton per hectare, please don't read the paper. It's a nonsense. I'm sorry, but so that the thing with the biochar is that it's a very sponge. That's a very good candidate to attract, to retain the nutrients from the compost, from manure, from also mineral fertilizer, and then it can be used as a slow fertilizer. And what we have observed in Burkina Faso, for example, is that with the very oxysol or feral soil, you know, very tropical soil, you can really improve with very low doses the parameters of the soil. So bioavailability of nutrients, also sometimes some sort of carbon storage. So if you are increasing the carbon quantity in the soil, also water retention is improved. So yeah, that's what I wanted to share with what we were doing with communities in Burkina Faso. And I was also mentioning the name of Hassan Nakro, who is really the professor in Burkina Faso. I know he's working also in Nigeria. So yeah, plenty of folks over there are doing amazing work.
Well, thank you so much for sharing, JT. We have another question. We have about a few more minutes for questions. There was a question here around the human waste and whether or not the extent that human waste is being taken into account as a short-term fertilizer in some of the forest gardens.
Not to my knowledge. I don't know if, Alyssa, maybe you have something to say?
Yeah, I think that question, it comes up a lot. And to our knowledge, no. Because we recognize that this was a garden, to put it very simply, like this was a place where people were growing food and people were intentionally fertilizing and using to grow foods and medicines and tools. And this is probably not where human waste ended up. That being said, there's no recording of in this in Gitsaic where human waste did end up. So it's a great question that I don't have the answer to.
Thank you. That does make sense. There's the old adage, you don't poop where you eat. So that
Exactly.
a couple of questions about the science, I guess, or the chemistry. So there was one of the chat that was answered around the larger phosphorus pool in the forest gardens and how that may have persisted over the last 150 years. But also wanting to tie in some of the work around building the thicker AH horizon and how that might compare with some of the soil organic matter work that has been doing within the context of climate change. Just so maybe we can, I guess the question is around, can we tie a line between some of the Indigenous practices and some of the practices that we're looking at with regards to improving soil health in the face of the challenges we have with conventional farming and climate change impacting soil ecosystems?
Amazing question. And so I'm going to try to be super short. In a very nutshell, for me, what we have observed with the communities in the Kitsa's Forest Garden, that's the perfect way to use organic matter or to really cycle carbon in the food forest system. Why? Because what is really key, I think, with organic matter is that organic matter must be processed. So it's not a question of getting a huge stock of organic matter in the soil that is not used by roots, by microbes in the soil. We really need to find a way to combine the different properties, the pH, availability of nutrients, together with water that can really improve microbial activity that can then process organic matter. Why? Because when organic matter is processed, you can release nutrients for plant system, for microbes. So you see that's a positive feedback loop. And then you are creating small molecules that can react with the minerals, creating what we call organo-mineral association, which is the very basis of getting aggregates and improving your soil properties. And what I have seen in Kitsa's Forest, I was really amazed because you have a puzzle with plenty of sand-sized particles, which is really bad to get aggregates. And we have observed with Alyssa, with everyone over there, really, really good at aggregates. So that's the best way to improve the soil properties while storing also organic matter for the climatic question.
Wonderful. Any other thoughts? There is one more question which I think is a great one. So there's a couple of questions that mentioned this. Just wanting to come back to the types of crops that were historically grown. And yeah, there's more questions about, what specific native plants, the quantities of foods that were potentially grown within these forest gardens, and how the processes of scaling up a forest garden to, for example, provide more security for a small to medium-sized community might come into play.
Yeah, I can take a stab at that. So the foods that were mostly grown in the overstory in Kitsalis included Pacific crabapple and beaked hazelnut. The forest garden in Kitsalis is about 100 meters by 100 meters. And in the understory, you'll find things like wild ginseng and lots of berry species. What am I thinking of? Red huckleberry, bunchberry, twinberry, which I know is technically poisonous, but is also a medicine. In Kitsalis, there's also so cool. There's a subalpine fir, which is out of its elevational range. So obviously it was planted there, and they used it for the sap, presumably. In terms of scalability, we've been thinking a lot about that recently as we've started working with Kicksand Nation. So in Kitsalis, the forest garden it's a hotspot. It's where you go to get your hazelnuts quickly when you need them. It's right next to your house. But there's also what we're trying to think of a name for it, landscape level forest gardens, where entire sections, like 3-kilometer long sections or more, were burned. And they were burned to help produce the black huckleberry, the like black hawthorn, red elderberry, all of these species. And these entire landscapes were burned, and they were huge. And there's stories from elders sitting down with your bucket, sitting down with your basket and collecting berries for an hour in one spot, and then moving the next hour and collecting berries for an hour in the next spot. And that's food security, you know, like that's abundance. And unfortunately I do have to go because I have to teach. So thank you for listening, but I'm going to bug you. So thank you so much, everyone. Have a nice day.
Thank you, Alyssa. And yeah, thank you for that answer. And I guess that's a great place to wrap up because we're right on time at the moment. Yeah, thank you all so much for sharing the great work that you're doing in the Soil Res 3 lab. There's been some great feedback in the chat about, this approach that you're taking to really to work in collaboration with Indigenous communities and start to really forward some creative and interesting, and as Jack said, some multi-dimensional, multi-use, multifunctional solutions to the various challenges that we face today. So thank you all so much for taking the time. We are going to wrap up this session. Our next session starts at, we'll be back at 10:15 for our panel discussion on farmer-led research projects. We will be closing this Zoom room, but you can be back using the exact same link. So we'll give you about 15 minutes to stretch your legs, and we'll see you back here at 10:15 or 15 past the hour, wherever you're from. Thank you so much for joining.
Thank you, everyone.